Cardano Mixer, a private transactions protocol for the Cardano Blockchain. Version 0.1. Cardano Mixer Development Team. 1. Introduction. 1.1 Motivation. Every year more and more personal data is getting collected by corporations and governments all around the world. Storage of real identity wallet pairs in centralized databases poses considerable risks for crypto assets owners. Personal data collection happens, for example, when a user sends crypto assets from a centralized exchange to a personal wallet. We believe that users of a public blockchain have the right to remain pseudonymous or to disconnect their real-world identities from their assets while remaining compliant with the laws of their respective jurisdictions. Cardano Mixer is a privacy solution for the Cardano blockchain. It is a protocol of a mixer type that breaks the public link between the sender and the receiver of assets on the Cardano blockchain, enabling private transactions. Several existing solutions tackle the private transaction problem in the context of a decentralized ledger. One that is more relevant to this work is the Tornado Cash protocol for the Ethereum blockchain. Cardano Mixer is an adaptation and evolution of that design. Notable differences in our protocol include off-chain proof verification and a completely different economic model. 1.2 On terminology. In this paper, we use the following terminology. A decentralized application or a DApp is a collection of software programs that work in a peer-to-peer manner and realize a certain function, in our case, enable private transactions on Cardano. A protocol is the description of DApp's logic. A mixer is a private transaction protocol where equal deposits are first collected in a common pot. Then, at any time, users can withdraw a deposit if they possess the knowledge of certain secret parameters for a particular deposit. The term mixing amount denotes the type and quantity of a digital asset in a single deposit for a particular mixer protocol. Anonymity mining refers to a practice of depositing assets into the mixing protocol for a prolonged time in order to capture the so-called anonymity mining rewards. The miners are awarded with anonymity points based on the number of deposits they waited before withdrawing. These anonymity points can be then exchanged for the anonymity mining rewards. 1.30 Knowledge proofs and setup ceremony. In order to break the link between the sending and the receiving wallets, we use zero-knowledge proofs of knowledge. In particular, we chose the Groth16 algorithm for the proof construction and verification. Our choice is motivated primarily by the proof size. Algorithms without trusted setup have the proof bit length significantly higher than the Groth16 algorithm. The difference is 20 times or more. With shorter proofs, we have smaller transaction fees than otherwise, which is especially important for mixers with smaller mixing amounts. Thus, we will have a trusted setup ceremony with users participating in the creation of a common reference string, CRS, a public bitstring that is produced using inputs from all contributors. For the protocol's security, it is sufficient that at least one contributor destroyed the random seed that was used to produce their input. To encourage participation, a significant portion of tokens will be distributed between the contributors. 2.3 Client app. In order to use the protocol, the user connects their wallet and chooses the desired mixing amount. 3 mixers will be available at launch with mixing amounts equal to 200 ADA, 1000 ADA, and 10,000 ADA, respectively. As the transaction volume increases, additional mixers for different assets and mixing amounts may be added. The client app supports deposit, withdraw, collect rewards, and claim rewards. Functions described above. The reward withdrawal amount should be equal to 5% of the mixing amount where M set membership symbol, 1.20. The client also has a generate report function that lists all interactions with the protocol according to the data stored on the user's machine. This report may serve as proof of compliance with laws of the user's jurisdiction. 2.4 Relay Node App. A relay node is run by users who want to provide verification and relay services to other mixer users. Stake function sends the required funds to the staking script corresponding to a particular mixer. After that, the relayer becomes eligible to accept. The client app requests. Start function activates the listening mode. Stop function deactivates the listening mode. Unstake function retrieve the staked funds from the staking script. It is only available at least 10 minutes after the last request has been processed. It should be noted that withdrawal and reward collection transactions include posting the public parameter H on the blockchain to avoid the double spending. 3. Protocol Token, Economics and Governance. 3.1 Mix Token. The protocol comes with a governance token with the symbol MIX. The token is used for two purposes. First, it facilitates voting on protocol improvement proposals and usage of the project's treasury. Once the governance mechanisms are implemented, token holders will control the parameters of the protocol, vote on improvement proposals, and determine the direction of the project's future development. They will also vote on the allocation of treasury funds as they are unlocked. Second, MIX tokens serve as collateral that relayers must stake to become a verifying and relaying service. As it was previously mentioned, proof verification is normally done off-chain by one of these relayers. Relayers submit transactions. 5. On the user's behalf, allowing empty wallets to withdraw funds and anonymity mining rewards. The details on staking are given in section 3.4. 3.2 Initial Token Distribution. The MIX token has a fixed supply of 100,000,000 tokens, minted at launch. The initial distribution of the token is summarized in the following pie chart. Below we give the description of each category. 15% of the tokens are airdropped to the participants of the trusted setup ceremony. 30% of the tokens are airdropped to the early users of the protocol. Another 15% of the tokens are airdropped to the early supporters of the project. Next, 25% of the tokens will constitute the project's treasury. Treasury tokens will start unlocking 6 months after the protocol release at the rate of 1% per month. The final 15% will be given to the initial developers of the protocol and the D-app. The team tokens will be unlocked in 3 vesting tranches, 5% at the release, 5% after 6 months, and the last 5% after 12 months. 3.3 Fees. Our protocol includes 2 distinct services. 1. Anonymity Mining. 2. Proof verification and relaying. Initially, we set the fees for both services at 0.1% of the deposit. These values and many other protocol parameters could be adjusted through governance if needs be. Here is the complete fee structure paid by a user initiating a deposit. 0.1% fee to the relayer and holders of the staked MIX tokens. 0.1% fee to the anonymity mining pool. The Cardano network fee on withdrawal transaction. The Cardano network fee on deposit transaction. The user withdrawing the funds does not have to pay anything. The relayer gets a network fee reimbursement plus their 0.1% upon the confirmation of the withdrawal transaction. This way, a withdrawal can be initiated from a freshly created wallet. When a user collects or claims the Anonymity Mining rewards, the fee is paid to the relayer. This fee is initially set to 1% of the reward plus the Cardano network fee on the transaction. For mixing assets other than ADA, we plan to use Babel fees when they are implemented. 3.4 Token staking. In order to capture fees, relayers must stake mixed tokens. Every mixer requires a certain amount of tokens, plus the mixing amount, to be staked to become a relayer for that particular mixer. This value depends on the mixing amount and is initially set according to Table 1. Table 1, Mix Staking Requirements. Every relayer is restricted to one submitted transaction per minute, withdraw, collect rewards, and claim rewards. There will be a separate scanner tool that searches for invalid transactions submitted by dishonest relayers. A transaction is deemed invalid if the verification algorithm run on-chain does not accept the proof posted by a relayer. In that case, the staked mixing amount is returned to the mixer. 75% of staked mixed tokens are returned to the project's treasury, and 25% of staked mixed tokens are given away as a bounty for exposing a dishonest relayer. 4 Mixer properties. Here we summarize the key protocol properties. At any time, the number of deposits in the mixer is always greater or equal than the number of withdrawals made, barring a dishonest relayer. Case. A dishonest relayer cannot cause damage to the protocol if there is at least one network node running the scanner app. Any deposit can be withdrawn once if the private parameters, K, R, and the withdrawal address are known. A deposit can be withdrawn only to the address selected during the deposit. No transaction front-running. 8. For each withdrawal, any deposit since the last moment when the number of deposits was equal to the number of withdrawals could act as the potential corresponding deposit.